To use strings in C++, we start by including the string class, and we use the name string from the standard library. And we declare first a string variable that is called S1. We can declare it like this, and it will be an empty string. And we can use direct initialization, which will have a copy of S1, and it will also be an empty string. Or we can do it this way, which is the same as doing it that way. But this one is called copy initialization, where we copy the right object into the left one, the one that is getting created, and that one is just a direct initialization. And we can declare the string like this by using the double ticks and write something between them. We can initialize a string, or we can use the direct initialization just this way. It can be useful if you want to repeat the same character for n amount of times. So if we print it, we can see that it has been repeated 10 times. And we can use a string like this to initialize it, or we can just write the name of the variable and the amount of times you want to repeat it and the character. And you should notice that we are using the single tick, not double ticks, because this one is a character, not a string. Like the parameter type is char, not string. And this one is an unsigned integer. It's a long unsigned integer, so it cannot be minus. If you add minus, you will get an error. And the difference between a direct initialization and a copy initialization. The copy initialization converts this literal into a temporary string, and then it copies that string into this object. It copies that string into this variable. And this one doesn't create a temporary copy. So this one creates the object in place without doing any extra work. But compilers optimize this copy operations. It doesn't have like a performance hit. So they both have the same performance when creating that string object. So the usual way we used to take input was using cin. And when you add a white space or tab, it's gonna read it until that point. So until you add a white space, that word will be written. If I write A and then white space B and then white space C, we're gonna get only an A when we output that string, because this white space operation marks it as an ended string, so the input has ended in the cin. But if you add like another variable, it will read that second variable after the white space. So if I write A, white space B, white space C, then now we can say that we have outputted A and B, because it reads the next input after white space or tab, etc. And to read a program that would repeat our words, like we would enter a couple of words separated by white space, like hello world, you can see that the program has printed the two words separated by a new line. So it's gonna print each word, and we have the end line, which is the new line separation. It's just gonna print all the words that are separated by either a tab or white space or vertical tab, but not by a new line. When you press enter, it's gonna print the words that it found inside the input that you have inputted. And it's pretty easy. You only create a while loop, and then you write cin and the extraction operator, the string for the input, and then you write cout and the word and end line. But if you want to print the line, the same line that you have entered, you want to print it. Like the same way you wrote that text, you wrote the input, you want it to exactly print it without separating each word. We use the getLine function that takes an cin and the string that we have created, and it doesn't have to be initialized. We can just write hello world. And as you can see, it has written for us, it had outputted the same text we entered. And if we entered an empty text, as you can see here, I checked if the line, the string, is empty that we are assigning the input to. We can use the .empty method to check if the string is empty. And we are checking right here, if it's not empty, we're gonna print. So if it's empty, it's not gonna do anything. It's not gonna print anything. Or we can print here if you want, cout empty string. Now if I just press enter, it's gonna print an empty string, and if I print something, it's gonna repeat it. To get how many elements are inside the string, we use the .size method, and it returns the number of characters in the string, not including any null termination, like 0. You might think that it's an integer, you should declare an integer to read the size, but it's actually wrong, because if we change to auto, we can see that the type has changed. And you can see that the size of the len became 8 instead of 4, because an integer type has different size than what the line.size returns. It returns a type of size t. So you can either use auto or size t. And size t, you can see it here that it's an unsigned long. So it cannot be negative, and it's much larger than a normal integer. So the correct way to use it is either using size t or auto. If we used integer, it might work for now, but it would lead to errors in the future, because now the code is simple and the string is simple. It will not cause an error at the moment. But if the size that it returns is too big, is way bigger than what the integer can hold, then it will cause an error. Since the type of len is size t, if we declare a variable that is -5, if len is greater than I, what the result would be? If we look at the console logs, we can see that it's 0, which means it's false. And to print it in a human readable way, we use the stdbool alpha, and then we write a comparison between parentheses. And it should be true because the len of this word is 11, of this string is 11. But since it's a size t, as you can see, the size t has unsigned long, which means it cannot be minus number. So you can't compare it with minus values. If we change the variable I to 2, which is a positive number, then we can get a real result, which is true because 11 is greater than 2. Or we can use declaration type and write inside it the line.size, or len type of I would still be size t. What happens when we assign a minus value, like -1, to this unsigned long I? Instead of it becoming actually -1, it will be the highest possible value for the unsigned long, so it would be the highest positive value. It's like a clock where it reaches 12. It's like it's resetting, so it becomes 1 after 12. And this one, when it reaches, as an example, this number, if we just add 1 to it, it will become 0. Like in this example, if we have a for loop and we declare the I to, and we initialize the I to -5, and we are comparing a signed integer to an unsigned size t, we would get the wrong result. It would not work even if len is greater than -5, technically, as we can see it. And what we should do instead is declaring the I to type of size t and initialize it to 0. And to use a for loop, we should use only size t or the unsigned long. Otherwise, if we use auto, it's gonna just declare it as an integer, as an signed integer. That would cause errors if the len is too large to be compared to a string. It's gonna cause errors if I is minus value, since we are comparing a signed integer with an unsigned long. Just using size t is the best option to compare strings using the comparison operators in the greater or smaller or equals. And for a string to be equals to the other string, if we write hello one with a capital H and the other one is with a lowercase h, we can see that the str is actually smaller than str1. But if they both have the same exact value, the same literal, then we can see that they are equal. And to print it correctly, we just write str is equal to str1. They both should have the same capital letters to be equal to each other. And if I made h to a lowercase literal and hello is an uppercase, you can see that the lowercase is actually greater than the uppercase. And if we look at phrase, which is 11, the length of it is 11, and this length, which is only 4, but phrase is actually smaller because it doesn't compare with the size of it, but the letter right here, I, is greater than E, so it's gonna be, this one is gonna be greater than phrase. Because if we change it to only he and hi, as an example, you would still see that phrase is less than slang when they are two words. But if we just change it to a, like a as an example, then it's gonna be the opposite. we can see that phrase is greater than slag because phrase has an E and this one has A, which is first before E, like A, B, C, D, E. And we can do mathematical operations with strings, like we can combine two strings. I mean, we can use the arithmetic operators with strings. We can combine two strings, like in this example we have hello word and st3. We declared, initialized it to st1 plus space, white space, and st2, which would produce hello word. And we can use plus equals, which means st1 equals st1 plus st2, just a shortcut. And I would combine the two strings together without white space. And if we have st4 equals st2 plus dot, we're gonna get just word and dot. And we can't combine two literals. However, we can combine them in another way if we have another variable and put it between parentheses and combine it with a literal. Then afterwards we can combine another literal to it with that string. And same as even if we use parentheses to combine two literals, we cannot do it. And to print the characters inside the string, we use the range for loop, which would print the characters inside the string. We first declare the variable, the character of type character, and we do the range and the string, and then we output whatever character inside the string is. So it would print each character and end it with a new line. And there are many functions for strings to work with strings. Let's say if I have a ranged loop that reads from st6, which is this one, and I'm extracting each letter from that string, each character, and I'm looking if it's unnum, which means that it would return true if the letter is a letter or a digit. And it's alpha means that if it's a letter, it's gonna return true. It's controlled character, it's gonna return true if it's a controlled character. And these characters are not written symbols or red letters, and these are used to format. Like if I add null terminator, like this one, you can see it has identified it right here and it's printed as control. And we have is digit, which means if it's a digit number, which means it would return true if it's a digit. Is graph means it's not a space but printable character. So if it's a white space, it will not count as a graph. Is lower, which means if it's a lowercase letter, it would return true. And we have to upper, which would change that letter to upper. And this, it would return the ASCII value for that letter. Whatever letter you pass in, it would return the ASCII value of it. And then we have to convert it to char. And you can use static cast if you are using C++ instead of using the C cast. And is print would return a printable character, space, or a character. Its punctuation is gonna return true if it's a question mark or exclamation mark, and a space it returns if it's a white space, like space tab, vertical tab, return new line, or form feed. And this upper is gonna return true if it's an upper letter. We can convert it to lower letter using the to lower, and we should cast it to char. And hexadecimal is gonna return true if it's a hexadecimal. To count the punctuation, we can declare a variable of type size t, initialize it to 0, and then we use the ranged for loop to access each character in the string s. And then we check if that character is punctuation, then we increment the punctuation count, and then we print how many there are. And now we can see that there are 3 in the hello world. You can see them right here. And to change the characters to uppercase, we should first declare a reference for the string s. We convert each character to upper, and then we assign that result to C, which is each character. And if we print it, we can see it right here that it's all uppercase. If we want to change the first character inside the string, we can just access it using the square brackets and putting the number 0, which accesses is the first one. And then we can convert it to upper. To make it more readable, we can declare a reference for the first character, and then we can reassign it. We can convert the first character to upper and then assign it to it after it has been converted to upper. So now we have the H here, right here. It's going to become a capital letter H. And if we have a string that is separated by white spaces, we can extract them and we can put them inside a couple of variables. And to be able to do that, we have to have a string stream. As you can see, we have declared the string stream that would hold the data inside it. And we created 3 variables for each of the strings inside the string, like for the name and age and weight. And then we just write the string stream and then the extraction operator and the name and then the age and then the weight. And you can see here that it has extracted them. Think of it like the cin. It's similar to the cin, the way we take input. And we don't need to do it we can do it in the same line, like here, weight. So now it will extract everything out of the string and it will put it in a sequential manner. Like we have the first is the John and the second word is 25 and the second word and the third word inside the string is 78.5. So sequentially it will go through them. Now we will write a program that would convert regular numbers to hexadecimal text string. First we need to take input from the user. So we need a string to take input. Then we are going to use getLine to read the data for each line, to read a string in a line without capturing the input once we click white space, and we'll pass in the input. Then we need a string to store the result for the answer. So we can store it in the result later when we calculate the digits. Then we would use size type to store the number, each number from the input. Then we also need a string of type size type to store the hex digits size of the string hex digits size. Then we write string stream ss and we store the input in it. Then we create a while loop and we write the string stream inside it and the extraction operator and then the n to extract the numbers from the string stream. And then we create an if statement and we check if n is smaller than the hex digit size, and if it is smaller we just append the result to it, hex digits, and then we access whatever is inside the hex digits with the number that we have extracted from the string stream, and then we print the result. And this one is just extracting the number from the string stream and it's checking if the extraction was successful, then it's gonna run the loop. Now we look at the debugger. Just gonna skip until the breakpoint. We will have to enter 3 numbers between 0 and 15, and we can see the variables. We can see the string stream is 12, 11, 10. You can see the hex digit size is 16, and this one was a default value. And if we step over, we can see that n now is 12, which is the first number in the input string stream. It's gonna check if 12 is smaller than 16, which is correct. It's gonna append the result. And it's gonna do that over and over again. Next one is 11 and the next one is 10. And then now it's not gonna run the while loop and it's gonna just write the result. And if we look at the result, it's CBA that was converted from numbers to hexadecimal text. And what really happened, we just accessed the string based on the number. So now if I access hex digits 12, we can just count from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one is in place 12, index 12 in the string hex digits. And 11 is the one before it, which is B. The 10 is the one even before B, which is A. So it becomes CBA.